I'll be going over a program that is not currently working and try to debug it to see what kind of bugs can we observe in a code. This program is a program developed for question 11 in 2018 midterm exam. The program is supposed to take an integer from the user and store it inside a variable named maxRange. Then your program should be printing a prime number that is randomly generated between 1 and this user entered integer that is stored in maxRange. A prime number is a number that is only divisible by itself in 1, but not divisible by any other number. Examples of prime numbers are 2, 3, 5, not 9, because 9 can be divisible by 1 and 9, obviously, but not 3. But 3, it is divisible by 3. 11 is the same, it can only be divisible by 1 and 11. 13 is the same, and so on and so forth. At this moment, you can look at the program. It is also there on Quarkus in the plenary lectures page. Kindly have a look at it and resume this video. Okay, now that you have resumed this video, first thing to find out why is your program not working is to try to test it and see at what point in time is it not working. So I'll compile my code and then try to run it. I'll start beginning with smaller ranges first and see if it works or not. Let's say I try to enter 5, it outputs random prime number 3. If I try to work with 4, oh, something wrong happened, is that it considered 4 as a prime number. Okay, so since we're generating random numbers, I suggest that we check if we're generating the prime numbers correctly or not, and then maybe try to play with the random number that's being generated so that we can try different numbers and see if our code is considering them as prime numbers or not. So it seems like here we're having a defect in knowing if a number is a prime number or not. I think this is one of the major issues. So the first thing that we can do is to try to use the debugger. I'm not placing any breakpoints. If you don't place any breakpoints, typically it will execute or it will start executing your code line by line, starting from the first line in your main function. So I did not put a breakpoint, but you can think of that breakpoint to be this part. Let me just do a word drop and resize this window. Yeah. At this point, we can see maxRange to be a random number or a garbage number, any arbitrary number. If we have or we step on this step over, we execute this line, we look at enter the maxRange, we can see that we are not, if I step into this line, we're not printing the maxRange. Using the debugger, sometimes this is an issue. So you have one of two options, either to have an end line here. So if I do this and try to debug again, compile because I changed my code, and then debug, oops, try to step over and then do this line, you can see that we entered or we had a new line in our code, and we entered this line or we printed this line after executing line 17. The other way is, if you don't want to print an end line, you can have another command after your printfs, which is called flush std out. If you have this in your code, this will try to flush anything that's being held in a buffer that is to be printed out but is not printed out for some reason. So if we compile, try to debug our code, and now do the maxRange, printf, again it's not printed. At this point it will be flushing anything in the output, and you will be seeing the enter maxRange in your terminal. And then you have the scanf if I try to step over this and try to enter a number, let's say 4. The problem here is that this 4 was not entered into maxRange after executing the scanf. In some computers it will be scanned, but in my computer it doesn't work. So if it doesn't in your computer, there are 2 workarounds. Again, just like the printf, there are 2 workarounds. The first is to have a space right here. So you compile because you change your code and you debug. Resize. You step over, enter maxRange, and then here after stepping over scanf, you can enter a number. At this point, you will be seeing the 4 in the maxRange. So this is one way. The other way is if you don't have a space here, and you compile your code, and then you debug. The other way is to enter the number. So I'll step over here, step over there, enter maxRange. Is before executing the scanf command, which is at line 19. It's highlighted in yellow. This means it's not yet executed. At this point, you can enter the number that you want to enter. So let's say 4, and then you press enter and then execute this line. At this point, you're going to see maxRange having the value of 4. So any of these 2 ways, either before the format specifier have a space, or before stepping over the scanf, enter your number, and then press enter, and then do the step over. So any one of these cases would work. Okay, so now we have is prime, a Boolean variable that's set to true. It's set to true. Then we have prime random. This is set to 0. So after executing this line, it will be set to 0. Here at this point, we are setting grand number to a random number, and then we're doing modulo maxRange -1 + 1 + 1, which is just basically saying that we're generating a random number that is between 0 and maxRange -1. Then we're adding this 1 there to shift the range to be from 1 until maxRange. So this particular line, there's no problem with it. So random number is being generated. This random number is 4. And then we have is prime to be set to true again, so it's fine. Here we have this for loop where it goes from the denom to be 2 until prime random -1, because here we don't have an equal sign at this point, but we are incrementing denom 1 by 1 every time we enter the for loop. Okay, so as we enter, we check the condition. If random modulo denom, is it equal to 0 or not? So when would it be equal to 0 is when prime random is divisible by denom. So if they're divisible, this equality will be true because there is no remainder. You divided a number by a number and there is no remainder, and hence this means that prime random was divisible by denom. So at this point, it's not a break, it's not a prime number, and here they're putting a break. So we check this is true because we're having prime random to be 4, and then we're breaking. If we try to execute this break, here's the thing, it broke, or it breaks from this for loop, but then let's see what happens. It doesn't break from this loop. We checked this condition. We found that this condition is false because is prime is true. So we skipped this part and we checked the condition, and we found that it's true, and we exited this for loop. And hence we determined that this random number is prime. So one fix would be that here we set is prime to be false, because at this point, if it's divisible by denom, then is prime should be false. So I'll stop the debugging, recompile my code because I changed my code, run a debugging session again to try to see now if in this case our program works or not. So is maxRange, reflush. Oops, I forgot to enter vscan f. So in this case, this is why I suggest that it's better to have a space here, so that in case you forgot, to put the space and you just stepped over, you'll have to rerun your debugging session as I did right now. This was an honest mistake, really, I didn't mean it. Okay, so I step over, I do the flushing, and here I stepped over. Now I'm waiting for an input. I'll enter 4. Bool is prime to be true, fine. Is prime is 0, random number generation is correct. Is prime to be true, I'll enter here. I'll find that it's divisible, so it is equal to 0 and hence it's true. Is prime will be false. I'll break from this for loop. I'll find that it's false, so not false. This means that this is true. So I'll go ahead, generate another prime number. Now I generated a 2. Is prime, it seems like this code is trying to think that a prime, like the number generated is prime unless proven otherwise. So we enter for loop. Since the number is 2, we did not enter inside here because the denom was set to 2 and the prime number generator is 2, and hence this equality sign is false, so we exited this. But we're considering the number to be true, so far I guess this code works if our random number generator is 2. This is because is prime is set to true and we're not entering the for loop because denom is set to 2 and this condition is false. So what we're doing here is that we're generating currently the random prime number to be correctly generated. And then since we don't have here a flush or an end line, so we're not printing actually the random number generated is 2, or the random number generated which is prime is true. So if I try to compile and maybe try to test it again with the input 4, random number generated is 2, which is true. 2 is a prime number. Let's try it with another number. Let's say 5. It's correct. Let's say I don't know, 7. Random number generated is 1. But wait, is 1 a prime number? Interesting. 1 is not a prime number, but it outputs that random number generated that is prime is 1. So it seems like our code does not work for the special case where the random number generated is 1. So in this case, you could have maybe here an if condition that says if your prime number is 1, if your random number generated is 1, then it's not prime. You need to repeat again. So if prime randnum is equal 1, you can set is prime to be false. You could have it as is, or you could have it between brackets. That's fine too. Let me save the code. So at this point, if I try to recompile my code, 1 will not be considered a prime number and I'll not get this. So let me try it again. So if I try a 7, okay, now I'm getting another random number, which is a prime number. Okay. Another way, instead of trying different random numbers like 7 and then 5 and then 4 and other numbers, you could decide to generate your own prime numbers as you are debugging to see actually if it's considered a prime number or not. Maybe it's a bit overkill for this code. It could be a little bit of a simple code, but you could still do it. So if I try to compile and debug, let me tell you a way where as you're debugging you can change the value of a variable. Okay, so here maxRange, you're flushing. step over, let me enter a number, let's say it is 7, and then I step over, is prime is true. Here I generated a random number, which is 1. I don't want like this one. Let's say I want to have another random number that's generated and see if it is prime or not. So let's say here, I'll double click. So if you find here, I go here and double click. Let's say I want to try to see if 11 is considered prime number or not. So I try to enter 11 here, press an enter, and then step over. Okay, then continue. Denom is 2, it starts with 2. 11, we try to divide by 2, it's not divisible, so it's false. You increment again, you see the 3, it's not divisible by 3. You try the 4, you try the 5, you try the 6, you try the 7, you try the 8, you try the 9, you try the 10. No need to try for the 11 because obviously it will be divisible by 11. And you check if it was 1 or not. So it's not prime. If it was 1, then you continue. This way I interfered with the debugging steps and I made prime random number to be 11 just for this case. If I continue again and enter the loop, or at this point I'm exiting the loop because I found out that 11 is prime. But if at this point or at any point in time I had this as 10, for example, which is not a prime number, it will go again inside the while loop, come into this line and generate another random number that is generated using grant. Again, you can change it if you want. If I want, I could change this to false if I want. Expression cannot be evaluated. Why is this? Yeah, probably you could not change the bool variable. I'm not sure why, but this is the case. I've never tried it before. Okay, so anyways, I couldn't change the is prime from true to false, but I guess we can change the numbers, so this is great. Yes, in here we can step over this and generate the prime number. This is just for testing purposes, and as you debug you can try to change the numbers, but again try to proceed with caution on this because it could be a little bit confusing. I've always said in my lectures that using a break and continue are not good coding practice. There are several reasons for that, but let me discuss one or more now. The break usually just breaks the loop that you're in. So if you're in a particular loop and you encounter the break, this would break this loop. What does a break mean? It means that even if the condition is true, it would just be considered to interfere with the condition and just make it false. If you're not familiar with a break, I guess you could think that it's useful. The answer is yes, it could be useful, but the problem is that it's bad coding practice, and it's only immature, I guess, coders try to use break in C. But this is just my opinion. But break is not a good coding practice because, again, if you're having here a nested for loop and you're doing a break thinking that the break will also break this outer loop, let me tell you that the answer is no. So for example, let's try debugging this code and see how does this break not break the outer loop. So if I do this, I enter a number, let's say it's 4, doesn't matter because I will want to have here, let's say a number that is just not prime. And step over and then find out that it's not prime. I'll break. I break just the inner loop, not the outer loop. Okay, so when I broke just in the inner loop and not the outer loop, I will still execute these conditions. So there could be conditions that I'm doing if I did not find a prime number or like in any other code, but I thought this break would break both loops. This did not happen. So this is one reason why break could cause a lot of confusion. You may think that you're in just one loop, but it turns out that you're in another loop as well, and you're not breaking from that other loop. This is one issue. The other issue is that the normal execution of any loop is to loop until the condition is false. So if you try to intervene with this, sometimes you may forget that you had a break at some point in time in your code, and you're not sure why your program is not working because your condition is so and so and so, but your loop is exiting for some reason and you did not see the break. Again, it could add a lot of debugging time. Okay, so what is the solution? The solution is to try to avoid this break, and instead of having a break, try to add to this condition something that will break your loop. So in this case, since we already have a Boolean variable named isPrime, you can remove the break and have here, and you continue looping in your for loop as long as isPrime is considered still prime and everything is fine. You never encountered isPrime to be false. The time or once you encounter isPrime to be false, this is the moment where you will stop this for loop, because you will check the condition and find isPrime to be false, and hence this condition will be false and you will exit this for loop. So this is one of the ways of how you can get rid of a break. This code is currently fixed since it's generating only prime numbers so far as I've seen. You can continue testing it either using the debugger and trying to change prime number, or you can just remove this and try different prime numbers and see if the random number generated, if the prime number checker is actually working correctly or not. This is it for this video, and please let us know if you have any questions. Thank you.